Welcome to this lesson on set notation and Venn diagrams. Today, we're going to dive into the language of sets used in your IGCSE Extended Mathematics syllabus. Our learning objectives for today are 1. Understand and use set builder notation. 2. Master the symbols for elements, subsets and operations. And 3. Apply these concepts to IGCSE-style exam questions. By the end of this session, you'll be able to read complex set descriptions and represent relationships between sets using standard notation. Let's start with how we define a set. A set is simply a collection of objects. We often use set builder notation to describe these collections. Look at set A. This is read as A is the set of all x, such that x is a natural number. The colon symbol represents the phrase such that. We can also define sets of coordinates. Set B is the set of all ordered pairs x, y, such that y equals mx plus c. This set actually describes every single point on a straight line. And finally, set C describes a range. It is the set of all x such that x is greater than or equal to a and less than or equal to b. If we want to list the elements directly, we use curly brackets and commas, like set D here. In this scene, we've introduced the foundational way to write and read sets. Now that we know how to define a set, let's look at the notation used to describe the contents and the size of a set. Consider set A, containing the even numbers 2, 4, 6, and 8. To describe the number of elements in a set, we use the letter n followed by the set name in brackets. Here, n of A equals 4 because there are 4 numbers in the list. To say that an object is inside a set, we use this symbol that looks like a curved E. This is read as 2 is an element of A. If something is not in the set, we use the same symbol with a diagonal line through it. 5 is not an element of A. Sometimes, a set has nothing in it at all. We call this the empty set, represented by a circle with a slash through it, or simply a pair of empty curly brackets. Finally, the universal set, denoted by the symbol epsilon, represents the set of all elements under consideration in a particular problem. In a Venn diagram, this is usually represented by the rectangle surrounding the circles. We've now mastered the basic vocabulary for membership and counting within sets. Next, we need to understand how sets relate to one another through subsets and complements. Let's define two sets, A and B. Notice that every single number in A is also found inside B. We say A is a subset of B. The symbol looks like a sideways U with a line under it. This means A could be smaller than B, or it could be exactly the same as B. Because A is strictly smaller than B, meaning B has elements like 4 and 5 that A doesn't, we can also say A is a proper subset of B. For a proper subset, we remove the line underneath the symbol. If we have a set C containing 6 and 7, these elements are not in B. Therefore, C is not a subset of B, and C is not a proper subset of B. We indicate this by putting a slash through the subset symbols. Now, imagine the universal set contains the numbers 1 through 10. The complement of A, written as A', contains everything in the universal set that is not in A. Since A contains 1, 2, and 3, A' consists of the numbers 4 through 10. In a Venn diagram, this is the area outside of circle A. We have now defined how sets live within other sets, and how to identify what lies outside a specific group. Now we come to the operations that allow us to combine or compare sets, union and intersection. When we look at two sets, we often want to know what they share or what they represent together. The symbol that looks like an upside-down U is the intersection. A intersection B means elements that are in A and in B. On a Venn diagram, this is the overlapping middle section. Think of it like a road intersection, where two paths cross. The symbol that looks like a U is the union. A union B means elements that are in A or in B, or both. In our diagram, this covers the entirety of both circles. Think of a labor union where everyone is brought together into one big group. Let's use a quick numerical example. If A is 1, 2, 3, and B is 3, 4, 5, the intersection is just the number 3, as it is the only element appearing in both lists. The union is 1, 2, 3, 4, and 5. Notice we don't write the 3 twice. In sets, we only list each unique element once. We have now covered the logic of combining sets using union and intersection. To pull all these concepts together, let's look at a typical problem you might see on an IGCSE Extended Maths exam. First, let's list the elements of these sets so we can work with them easily. The universal set is just the integers from 1 to 10. Set A contains the prime numbers in that range, 2, 3, 5, and 7. Note that 1 is not a prime number. Set B contains the even numbers, 2, 4, 6, 8, and 10. First, find the number of elements in A union B. The union combines both sets. The elements are 2, 3, 4, 5, 6, 7, 8, and 10. Counting them up, the answer is 8. Next, let's find A intersection B prime. B prime is everything in the universal set that is not even, which means the odd numbers, 1, 3, 5, 7, and 9. Now what does this share with set A? Both sets contain 3, 5, and 7, so the intersection is the set containing 3, 5, and 7. Finally, is A a proper subset of B? Since there are elements in A, like 3, that are not in B, A cannot be a subset. By breaking down the notation step by step, even complex-looking exam questions become manageable. Let's conclude by reviewing the symbols and concepts we've mastered today. We have membership symbols, the number of elements notation, empty and universal sets, subsets, union and intersection, and finally, the complement. We started by learning how to read set builder notation, which uses a colon to mean such that. We then moved into the grammar of sets, how to say an item belongs to a set using the element symbol, and how to count them using n of A. We explored the relationship between sets, distinguishing between a subset, which can be equal, and a proper subset, which must be strictly smaller. Finally, we looked at operations like union and intersection, which are the building blocks for solving Venn diagram problems. Let's check our goals. Read set notation? Yes. Use set symbols? Yes. Remember, in your IGCSE exam, the key is to list the elements of each set clearly before you try to find unions or intersections. This prevents simple counting errors and makes the logic much clearer. You are now ready to tackle set notation and Venn diagrams with confidence. Good luck with your revision.